Problem statement. Water is pumped between two reservoirs in a pipeline with the following characteristics. Diameter is 300 millimeters, length 70 meters, F 0.025, sum of K 2.5. The radial flow pump characteristics curve is approximated by the formula HP 22.9 plus 10.7 Q minus 111 Q squared, where HP is in meters and Q is in cubic meters per second. If zeta 2 minus zeta 1 is equal to 74 meters and the minimum required flow discharge is 0.2 cubic meters per second, determine the minimum number of pumps you would use. Would you use pumps in parallel or in series? Justify your answer. So in this problem, they're asking us if we should use pumps in parallel and pumps in series, and how many to satisfy the minimum flow discharge, which is 0.20 cubic meters per second. So Q minimum is equal to 0.2 cubic meters per second. Okay, and this problem is giving us the pump curve, and the pump curve is given by this equation. So the HP of the pump curve is equal to 22.9 plus 10.7 Q minus 111 Q squared. So one single pump can give us a maximum head of 22.9 meters. So if Q is equal to 0, this HP will be 22.9 meters. So the maximum head that one single pump can give us is 22.9 meters. However, in this problem, we have a difference of elevation between the reservoirs of 74 meters. So this is elevation of 2, and this is the elevation of 1, and zeta 2 minus zeta 1 is equal to 74 meters. So, so the minimum number of pumps that we need will be 74, okay, divided minimum number of pumps will be equal to 74 divided by 22.9. Okay, and this gives us 3 something. So 3 point something. Of course, we cannot use 3 point something pumps, so we have to use minimum 4 pumps. Now, if we use 4 pumps, we have to check that the flow is larger than 0.2 cubic meters per second, right? Because we have to satisfy a minimum flow discharge of 0.2 cubic meters per second. Okay, so we know that we have to use as a minimum 4 pumps in series, right? 4 pumps in series because we need a minimum head of 74 meters. Okay, so we have the pump curve. So this is the pump curve equation. And now we have to get the system curve or the hydraulics curve. So we know that the actual flow is the intersection. So this is the head and this is the flow. The actual flow is the intersection of the pump curve, okay, and the hydraulics curve or system curve. So this is the pump curve, and this is the system curve or hydraulics curve. Okay, and the intersection of those curves will give us the actual flow discharge. So I already have the pump curve for one single pump, and now I have to get the hydraulics curve. Okay, so let's do that. We know the hydraulics curve. Or also called the system curve, comes from the pipe, right? So HP is equal to the difference in elevations, plus FLD plus sum of K times Q squared divided by 2 times gravity area squared. So that will be the equation for the hydraulics curve. Okay, so HP here then we can replace values. HP will be equal to zeta 2 minus zeta 1. According to the problem is, let's see here, is 74 meters. Plus F is 0.025. The length is 70. The diameter is 0.3 meters. The sum of local coefficients is 2.5. All of this times Q squared divided by 2 times gravity, 2 times 9.8, and times the area squared, which is pi 0.3 squared divided by 4, and all of it to the square, because it's area squared. So using the calculator, this will give you HP is equal to 74 plus 85. Oops, it's going to be 74 plus 85 times Q squared. Okay, so that will be the hydraulics curve. So this is my system curve. And my system curve, we don't care here how many pumps we use. The hydraulics curve doesn't change depending on the number of pumps. Okay, the system curve will be fixed. Now, we know that we have to use as a minimum 4 pumps in series. Okay, so what we have to do now is we have to match the HP. We have to match the HP of the system curve with the HP of the pump curve, of the pump curve. Okay. So the HP of the system curve is 74 plus 85 Q squared, and I have to match that with the HP of the pump curve, right? I cannot use one single pump. One single pump is this one. This is the pump curve, but for one single pump. I cannot uh, I cannot simply use one single pump, because if I use one single pump, the flow discharge is going to be zero, right? I need a minimum of 4 pumps. And I explain why we need 4 pumps. So I have to use minimum of 4 pumps. So I have to multiply 4 times HP of the pump curve. And that will give me 4 times. Okay, so that will be 4 times. So this is going to be 4 times the pump curve, which is 22.9 plus 10.7 Q minus 111 Q squared. Okay? So if I solve this, it will give me a flow discharge of 0.227 cubic meters per second, which means that this is 227 liters per second. Now I have to check if this flow is larger than the minimum flow I need. The minimum flow I need is 0.2 cubic meters per second. Okay, so we know that from this we can see that this value is larger than 0.2. So I am satisfying the minimum flow discharge. Okay, then we can say we satisfy the minimum flow discharge, because 0.227 is larger than 0.2. Okay, Therefore, the minimum number of pumps we need is 4 pumps in series, right? 4 pumps in series. We need 4 pumps in series, okay? We cannot use pumps in parallel. The pumps in parallel will not increase the head. So if we use 4 pumps in parallel, my head will still be 22.9, right? And 22.9 is smaller than 74. Therefore, if I use 4 pumps in parallel, my flow is going to be 0, right? So I cannot use pumps in parallel here. I have to use pumps in series, right? So again, we need to use as a minimum 4 pumps in series.